Be working on 6C from the Cambridge Unit 1 and 2 Methods textbook. So we are going to be working on understanding factor and remainder theorem. So the first thing I want us to think about is when we did long division before, we had a remainder. So with this, our remainder we had was 53, and we wrote it as 53 over x minus 3. Now, the way to think of if it's a factor is thinking about null factor law, it will equal 0. So if we times both of those values together, when as one of them equals 0. So in that case here, if I'm dividing by x minus 3, that means to make it 0, x must be 3. So if I substitute that in as 3, I will then get what's left over, which is 53. So that gives me my remainder. So with remainder theorem, if we plug in a value for x and we've got something left over, it is not a factor. So that's something we just need to be thinking about. So this is just our x value that we are plugging in. Likewise, if I do it again here, I've got 2 that is left over if I do long division. And again, if I then go, okay, I'm just going to substitute the 2/3 in because to get x by itself and to make it equal 0, I'll add 2 to the other side and then divide it by 3. So if I put in 2 over 3 into my original equation, it's going to then give me what is left over, which is 2. Factor theorem is identical as what I've just gone over. But in this time, when we plug that value in, it is going to equal 0. So let's look at this question. We've got x to the power of 3, take away x squared, take away 4x plus 4, and we're wanting to show that x plus 2 is a factor. And then hence, we're going to find all the other linear factors. So the first thing is we are going to use factor theorem. So that means if I'm using factor theorem, I'm just going to look at this factor here and go, how do I make that 0? Well, x must be -2. So I plug in -2 for x into my equation. -2 to the power of 3 is -8. -2 squared is 4, so take away 4. And -4 times -2 is +8 plus 4. We can see straight away that that is good, will give us 0. That therefore tells me that x plus 2 is a factor. Now, to work out what's left over, we need to do our long division from the previous lesson. So I start off with everything in the correct order of my powers. And I then go x to the power of 3 divided by x gives me x squared. Then I go the opposite way to work out what's been shared. X squared times x is x cubed, and x squared times 2 is +2x squared. I take away what's been shared, so that cancels out that first term. -x squared, take away 2x squared gives me -3x squared. I then go the opposite way. -3x squared divided by x gives me -3x. I go the opposite way to work out how much I've shared. -3x times x is -3x squared, and -3x times 2 is -6x. I take that away. If I take that away, I look at what's left. Well, that first term's cancelled, and -4x, take away -6x gives me 2x. I continue this process. 2x divided by x gives me 2. I work out what I've shared. 2 times x is 2x, and 2 times 2 is 4. I take that away, and I've got 0. 4 take away 4 is nothing. So that means I've got a linear factor here, which is x plus 2, and I've got a quadratic factor, which is x squared take away 3x plus 2. Now with this, I can continue doing long division and using factor theorem, or I can factorize my quadratic. So I know that AC is equal to 2 and B is equal to -3. So that means I will be looking at 1 and 2. And if they're both negative, they'll add up to -3. So now straight away, that gives me it in factorized form of x plus 2 in brackets, x minus 1 in brackets, and x minus 2 in brackets. Okay, show you that x plus 1 is a factor of x to the power of 3 plus 2x squared minus 5x, take away 6, and hence find the other linear factors. So the first thing is we need to check if x plus 1 is a factor. So I'm using factor theorem. That means I'm going to substitute -1 in as x. If it equals 0, then it's a factor. So -1 to the power of 3 is -1. -1 squared times 2 is +2. -5 take away 1 is 5. Take away 6. Okay, so now we've got -1 plus 2 is 1. 1 plus 5 is 6. 6 take away 6 is 0. So that means it is a factor. We now need to use our long division to make sure your powers are all lined up. And we've got x cubed divided by x gives me x squared. I go the opposite way. X squared times x is x cubed. X squared times 1 is x squared. I then take what I've shared away. It cancels out this first term. 2x squared, take away x squared is x squared. I continue. X squared divided by x is x. I work out how much I've shared. X times x is x squared, and x times 1 is x. I cancel out what I've shared. So that is -5x, take away x is -6x. So now I need to, again, go -6x divided by x equals -6. I'll work out what I've shared. -6 divided by x is -6x, and -6 times 1 is -6. I take this away. This term's already cancelled, and -6, take away -6 becomes 0. So I now know I've got a linear factor and I've got a quadratic factor. So this is where we need to factorize the quadratic. So we're going to be looking at a times c, which is -6, and b equals 1. So the two numbers that times together equal 6 will be 2 and 3 because there's one difference. One of them will need to be a negative to add up to 1. So it'll be -2 and 3. Straight away, I'm able to write it in x plus 1 in brackets, x minus 2 in brackets, and x plus 3 in brackets. So I've got my three linear relationships. Now, rational root theorem is something we need to understand. So our roots for a polynomial are always going to be able to tell us our x-intercepts. Now, if a polynomial has a rational root, where it's always going to be looking at listing all of our integers down, or first the constant term over the leading coefficient. And that will give us all the possible values that could be a root, so it could be a factor. And that will allow us to make it a lot simpler, so we're not just guessing and inputting a value. So let's have a look at this. So straight away here, if I've got 2x to the power 3 minus x squared minus x minus 3, the first thing I need to think about is what is my constant term, so -3. So what are the factors of -3? So I've got 1 and 3, and they can be positive or negative. Likewise, the leading coefficient, so looking at with the highest power, I've got a 2 there. So that means I can divide the 2 by a positive and -1, and a positive and -2. So that is going to give us all of our values when we look at one of these factors of the constant term over the factors of the leading coefficients. So that will be 1 over 1 is 1, positive and negative. 3 over 1 is positive and -3. 1 over 2, positive and negative a half, and 3 over 2, positive and negative. So these are all of our examples. So that means we've only got, in this case, 8 values that we need to check to see if they are a factor. And I just picked one, so I put 3 over 2 in, and that then got me to 0. So let's have a look at this question. It says use the rational root theorem to help factorize 2x to the power of 3 plus x squared minus 13x plus 6. So the first thing we need to do is identify our factors for our constant and also our leading coefficient. So our constant is 6. So we got 1, 2, 3, and 4. And so 1, 2, 3, and 6, positive and negative. And our leading coefficient is 2, so we've got positive and negative 1 and 2. So if I want to state all the possible roots, I'm just going to start off by using 1, 1 over 1, 2 over 1, 3 over 1, 6 over 1. So that will just give me my first 4, positive and negative. Then I'll move to the 2. I've got a half. 2 over 2, I've already got that. 6 over 2 is 3, I've already got that. And 3 over 2. So I've only got 6 positive and negative possibilities. Now, we only need to find one, and then we can find the rest after we've done long division. So let's check which rational roots are factors. So let's start off by just putting in 1. We've got negative 4. So I'll put in a half, and I got 0. I've put in 2, and I've also got 0. Oops, and that one there should have been negative 3. So we can see that all we need to do is work out what are our factors, and then we're able to use them to factorize it. But ideally, you find one and then you factorize. So let's use the rational root theorem to help factorize x to the power of 3 minus 4x plus 3. So again, we are finding our factors of our constant term 3 and factors of our leading coefficient. So this one's easy. 3 is just positive and negative 1 and 3. And our leading coefficient, it's 1, which limits the amount we have to look at. So that means 3 divided by 1 is 3, 1 divided by 1 is 1. So we've got only 4 possible factors. Now we just need to check. So we're just substituting those values in. In this case, I found 1. So I stop. I do long division. And that means because I plugged 1 in, it's going to be x minus 1. So that means I go x to the power of 3 divided by x equals x squared. I go back in the opposite way and see what I've shared. X squared times x is x cubed. X squared times negative 1 is negative. And x squared times negative 1 is negative x squared. I just fixed it up because there was a small mistake on this slide. Okay, let's move on. So then I'm just going to take that away. So if I take away that my x cubes are cancelled out, you probably noticed before I do this, I put a 0x squared, and that's because even though we didn't have an x squared in there, we still need to show it so that way we can do this step, which is I've got 0 groups and I'm taking away negative, which means I'm going to have 1 group of x squared. So then I look at this x squared and I divide it again by x. X squared divided by x is x. I go back the opposite way. X times x is x squared. X times negative 1 is negative x. I take that away. This x squared is cancelled because I've shared it. And negative 4x, take away negative x, that turns into plus and gets to 3x squared. Sorry, gets to negative 3x. I then continue. Negative 3x divided by x is negative 3. I work out what I've shared. Negative 3 times x is negative 3x, and negative 3 times negative 1 is positive 3. I take that away and it gets to 0. So this gives me a linear factor and it gives me A is quadratic. I can then use my basic understanding of is quadratic. Factorization, I look at two numbers. Whoops. I can look at two numbers that times together to equal 3, will be 1 and 3. One of them has to be negative, and they need to add up to be B. Now, but if I look at that, it makes it really challenging. So the only other way I could factorize this further, which is using the complete this square, and then potentially using the difference of two squares rules to finish this off. But I'm just going to leave it in this form with a linear and a quadratic. Okay. There are special cases that we need to understand. So sums and differences of cubes. So x to the power of 3 take away a to the power of 3 is going to equal x minus a in one bracket and x squared plus ax plus a squared in the other. So if we're factorizing x to the power of 3 minus 8, if I substitute 2 in, we instantly know it's going to be equal to 0. So if I wanted to do long division to check this out, remember as I write it, I'm just going to write a 0x squared because I've got none, plus 0x minus 8. So again, x to the power of 3 divided by x is x squared. We go back the opposite way. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And then I take that away on what I've shared. That gives me 2x squared. I continue. 2x squared divided by x gives me 2x. I work out what I've shared. 2x times x is 2x squared, and 2x times negative 2 is negative 4x. I take away what I've shared. This is cancelled out, and 0x plus 4x is 4x. Again, 4x divided by x gives me 4. I go back the opposite way. 4 times x is 4x, and 4 times negative 2 is negative 8. I take that away, and I get 0. So that gives me it in terms of x minus 2 as a linear factor, and a quadratic factor would be x squared plus 2x plus 4. If we look at this relationship here, we can quite easily see that if here, if I've got x to the power 3 minus 8, we can see that if that 8 is 2 to the power 3, it fits into this mold. So it's something that we just need to memorize. Same thing if we're looking at the sum of cubes. We've got x to the power 3 plus a to the power 3. So we're just going to do a similar one where we can already see the answer. So if I have x to the power 3 plus 8, so with factor theorem, so that should be a negative there. If we substitute negative 2 in, we know we're going to get 0. So that means because we substitute negative 2 in, it would have been x plus 2. So we're just going to apply this again. Just make sure you can see that because we didn't have x squared or x, I've just put a 0x squared and 0x in. So now I'm going to go x to the power 3 divided by x is x squared. X squared times x is x cubed, and x squared times 2 is 2x squared. That is what I've shared. I take that away. That cancels out this term, and 0x squared take away 2x squared is negative 2x squared. I again go negative 2x squared divided by x, and that gives me negative 2x. I go the opposite way. Negative 2x times x is negative 2x squared, and negative 2x times 2 is negative 4x. I take away what I've shared. This term's cancelled out, and 0x take away negative 4x gives me 4x. I continue. 4x divided by x gives me 4. I go back the opposite way to see what I've shared. 4 times x is 4x, and 4 times 2 is 8. That's what I've shared. I take that away and I get 0. So now I've got a linear factor and I've got a quadratic factor. And we can see that it's in this same form. So when we're dealing with sums, a sum and the difference of cubes, I really do encourage you to just to make sure that you know these formulas off by heart.